All right, guys. Wait, so everyone can see this, right? Or is it a little dark? I mean, light. Yeah. Can you guys hit the lights?
Yeah, I was
All right, so what when you saw this, what were you guys thinking? Malcolm? Wrap everything in a promise. Okay, I would think that too. All right.
Well, so I was stuck at first.
You were what?
I was stuck.
Stuck?
Yeah. So, but the idea of the promise is that you do the thing, and then you check if it happened or not, and then depending on that, you resolve or.
Yeah. So why were you confused?
Because
like what?
Cheerio works.
Huh?
I didn't know how Cheerio.
You didn't know how Cheerio works. Okay, that's valid. Anyone else? Richard?
I was thinking the same thing about like wrap everything in promise, but I was stuck as well on how I was going to do that. I was thinking maybe put the array of images in the result. There we go.
Yeah, I mean, yeah, so you guys were thinking exactly how you should be thinking. So here's the deal, right? Like, there's going to be many times where you're going to be working with code that other people wrote, right? And that's probably legacy code, okay? So does anyone understand what the term legacy means? Huh? Something left behind? It's like old code, yeah. It's like things that were cutting edge at that time when it was built, but then over time, technology advances, the company changes, you know, like the product evolves, right? So like the old code starts getting left behind, right? And it becomes legacy, okay? And you're gonna hear terms like that a lot, and that's what a lot of developers end up having to do at their jobs, right? Especially like if you work at a bank or something, you're probably working on their legacy code and upgrading that, because like usually bigger corporations have like, they use technologies that are much more outdated than like, let's say startups, right? Does anyone know why that would be the case? Richard and Robert?
Because bigger companies have so much data that they have to transfer over.
Okay, yeah, there's definitely a lot more data they have to transfer over. Robert?
I think there's just a lot more hoops to jump through to like.
Lots more hoops. To like what? Invent?
To like, you gotta build something like there's just more like it's just a lot more people that has to go.
Like, so you're talking about like bureaucracy, like in the corporation? Okay, yeah, definitely, yes. Serge?
I just want to know why you keep having the flow of the workflow at the company as everything relies on the software. Sure. Back in the 90s,
Mm-hmm. Yeah, so definitely, like, I think one of the biggest reasons is that it's that, you know, because they're a much bigger company, right? They have way more moving parts, right? And they have an established business, right? They have an established business, and whatever they're doing is working for them, right? They've been probably in business for 20, 30 years, and whatever they're doing is working for them. And it's actually a big pain to it's a big pain and stress to the development team to kind of change all of that and make it up to date with like whatever technologies there are right now. And that probably will cause inconvenience to their users, right? Which is more important, right? Because if they cause inconvenience to their users, they're gonna lose money, right? And they're gonna lose customers. So usually, like, that's why like bigger companies have all this legacy code. Is not because they're lazy and all that, right? They definitely have the money to upgrade everything, but they just don't see the business benefit of it just yet until they hit like a brick wall and they see like the whole world is changing in a drastic way and they have to keep up. That's when they do it. Okay. So yeah. Anyways, going back to the code, right? So back to that scenario, right? Like this is some sort of legacy code, right? The entire backend back in the day was usually written using callbacks, right? So that's kind of like the first thing you should see, right? It's that this function doesn't return anything. It has a callback, right? It has a callback, right? And that's how it's giving back the data, right? So what's so what does this function kind of look like? Like other than the Cheerio and stuff, but like, you know, the fact that it has an array and then you're pushing things into the array and then you're giving the array data back into through a callback, Malcolm. A loop, okay. Yeah, but like I'm not like what other like yeah. Okay, yeah, it is okay technically, right? But I'm more asking like what does this kind of resemble? Like what kind of function have we worked with before and we've actually built in like unit 1? .map, right? Yeah, this kind of looks like .map, right? Looks like an array method, right? What's interesting is, right, like there's going to be so many times that you guys will be working on code and you'll see, like this looks like a problem that I've already solved before, and this is very universal. Like you'll see that like complex problems are actually simplified down to the same simple abstract solutions that other functions that you've built use, right? And that's why we learn things like data structures and algorithms and stuff like that, because they're all just using the same thing, right? But you know, like like as Lori said, right? Like he never really understood Cheerio and doesn't really know how it works, right? And that's fine, right? That's not your job to understand it. What your job is to understand is to know what the inputs are, right? So the input you see is page URL and page HTML, right? And you also have to know what the output is, right? The output is array of images, right? Anything in between, like all that, like the meat of the function, you don't really need to know to like promisify it, right? You don't really need to know what it does. You just need to know the inputs and outputs, and then just wrap it, kind of, right? That's essentially what you have to do to make this into a more modern function, right? So that's another point I wanted to prove, that you're gonna have to you're probably gonna like for your capstones and all that, right? You'll probably find frameworks and other libraries on NPM that you will download and use, but you'll see like, hey, like this function doesn't return a promise, right? Like, or it doesn't work in a certain way that you would want it to, right? So what you would do is you would probably like take that function and wrap it around your own custom code and make it work the way you want it to, so it fits in your flow, right? Does that make sense? So like you know, going forward, like you'll see Tak and I like talk a lot about this stuff where it's more just like system design and like, you know, overall design and architecture of like program and understanding things like that, because that's very important, right? Like as I said, like when you go to top companies, right, and you go through their interview process, these are the type of questions they ask, because like anyone can make a loop. Anyone can solve like, data structures problems. You just got to study it. It's like that. It's like, studying for the SATs or something. It's like the more you practice it, the better you get at it, right? It's not really anything else, right? But things like understanding like design, it's critical, okay? So anyways, going back, right? So can someone tell me what, like, in terms of coding it, what should I do? Like, what's the first approach I should make? Jay?
So what I would do is, I'm not really sure if you want us to change the numerical function, but supposing we want to keep that same exact function, I would just, well, we want to, okay, so yeah, so let's do, so let's create a function named get images and page promisify.
So why do you think we're changing the name? Why aren't we using the original name?
Because the original function will not return a promise and this one will. So maybe we have option using. Oh.
Exactly, right? You wanna keep the legacy code intact at that point, right? You don't wanna erase it completely and like you wanna keep it there because it's not harming you, right? Unless your boss is saying, all right, just scrap all that shit, right? But for the most part, you would want to keep the legacy code there because what if you make a mistake, right? What if you make a mistake and then you don't know how to revert back, right? Then you're kind of screwed, right? But yeah, so anyways, and also it's also kind of very clear that this is like, there's two versions of this, right? Just like in the FS module, you see that there's read file and there's read file sync, right? So you know that there's two versions. So this also tells you that there's going to be two versions. One is the original version and the other is the promised-ified version, all right? All right, cool, what's next?
So I would say only the page URL and the page HTML parameters. We don't need to call back things.
Why?
This one will be returning a promise. When we have a promise, we don't need to call back anymore.
Okay, so that's a very important understanding to have, okay? That when you're using promises, when you have a function that uses promises, you do not need callbacks, okay? That's the whole reason why we have promises, is to avoid that callback hell, right? Do you guys all remember and understand what callback hell is? Yeah, it's like callback within a callback within a callback within a callback, right? Why is that considered callback hell? Like, why is that considered a problem, right? How? Why?
Oh yeah, I can see like what's happening at this. I mean, that's you run it a few times.
Yeah, and what if you run into an error within any of those callbacks, right? How would you mitigate that, right? That becomes way more complicated, right? Like it's like you have this big function and then you have a callback in there and then you're also testing for its error, right? And depending on if it's successful or error, you have to do another couple of options, right? So you're constantly nesting things, right? And that's why we use promises, right? To completely eliminate that. All right, cool. So you know that for sure, all right? That if you're using a promise, you're not using a callback, all right? Cool, what's next? Erica, you're raising your hand? Yeah, sure, give it a shot.
Well, I then, sorry. So then I then added the variable.
Okay. Yeah. Okay, so you're basically transferring over the old code, right?
Yeah.
So where do you go up to?
That's there. And then start the return promise.
Wait, what? Where?
No, you also do the variable.
Yeah. So you're basically copying over the old code. Like what should I copy over? All of this?
Not all of it up to before the callback.
Okay, cool. All right. So yeah. So you like as a developer, right? Let's say this is way more complicated than this, right? You don't really care to know what exactly all these things are doing. You just know that it's necessary, right? Okay.
And then you just resolve with that array of images.
And then you just do resolve array of images. Yeah. Wait. Can you? Okay. So all right. So let's look at this for a sec because it kind of tricked me a little too, right? Okay, so you have an array of images, and then you have all this code that that you don't really know and care about, right? But then you know for sure that array of images is going to be the output, right? That's going to be the output that's coming out of the function, right? So your next intuition is like, hey, let's call resolve on that. The resolve is not defined anywhere here. Right?
Oh, because you did this into the new promise.
Exactly, right? Cool. So yeah, so for this to be a promise function, right? You have to create a new promise and return it, right? So you do return new promise, okay? And promise is just an object, right? It's just an object, right? So you can see it, like just like how you do new date or new, some sort of class name, right? That's what you're doing, right? New promise, right? But what promise takes in as a parameter, right, is what? A callback function, yeah. And the callback function takes in what? Resolve and reject, right? Cool, so now I should do what? I should take all of this and put it inside. The promise is callback, right? Cool, is that it? Are we done? Yeah, right? Seems about right. So here's a question, right? Why should we do, why aren't we doing reject at this moment? You want to answer?
No,
All right.
I would do a reject,
You would do a reject?
because like, if the array turns out to be empty,
Okay.
that means something without parameters involved.
Okay.
So
Really?
I'll console log like, oh,
What if you go to a page and actually it has no images? then you consider that an error. You know what I mean? So errors, I see where you're coming from, and that's also like a design decision, right? But I don't think errors should determine what, like, how many things are being populated, because 0 is actually something, right? So I would have an error to figure out if like the page HTML is actually an HTML string or not, things like that, okay? But for this case, let's keep it simple and not really worry about that. But errors should be things that should break the function, right? But it shouldn't be something that can happen, right? Any other questions?
With the reject, maybe if, like, whatever data that we get back, if we couldn't get any data back, if we reject that.
So you want to reject back an empty array?
No, not an empty array, but like, if there was something wrong with the data we're trying to retrieve, it came back wanting to whatever, then we reject that.
like, if for some reason you got a response that it wasn't an image, it was like,
Yeah.
data or something.
Yeah.
Yeah, so basically definitely, yeah, you would have reject if, like, for example, your HTML was wrong, right? Like that string was wrong, and you can't parse it to find the images, right? So things like that you would definitely reject. Yeah.
was gonna ask how do you, there's my part. I was gonna ask, how do you pass more than one piece of the result?
Oh, you have to pass it through with like an object.
Yeah.
Okay.
It's all one parameter.
All right. Let's. Oh yes. What's up?
Can you do the return process like after lines 20 to 26? Or is this the best practice to all go inside like returning?
Oh no, yeah, you can do that too. Yeah, definitely. Yeah. I think it depends. Like guys, come guys. So that's an interesting decision, right? So what you're saying is have the comments come after all this processing, right? But here's the thing, right? What if like something went wrong here and we wanted to capture that? That's why you would wrap it wrong. So like the case that they were saying, right? So let's say like for some reason Cheerio couldn't load that information, right? And you somehow knew how to capture that, you would reject it, right? So for scenarios like that, okay, that's what it would happen. All right, guys, let's take like a 5-minute break and then we'll come back. Right? Let's take a 5-minute break. But only one will invoke. Because you can invoke any resolve or reject. So like, so this is here. Can you get, I have to do something. Sorry. Yo, Michael. Right now. It's just uniform. Yeah, it's on canvas and it's the same thing as last time. So they just go to that GitHub and then they work on that file and then they. Oh, so how long do they have? 2 hours, but it started taking us 2 hours.
And how are they submitting it? Zip?
Yeah, they're submitting the files directly to Congress,
Okay.
right? Just like last time. And it's really just map, find an array, and two class problems. That's it. Find in an array. Find in.
Check to see it. Oh, it's like elements. I thought you said find an array.
I do like that. Oh, yeah.
I don't know why. Very outer parts of the inside.
Yes, yes. So it's like, yes, yes. So then they can
All right, guys, sit down. All right, so So what's, guys. So what's another way of writing this same function? And what's like the drawback of writing it this way? What's the drawback of writing it this way? I need you guys to start thinking in this kind of manner. So there's another way of writing this same code. But yeah, there's basically two ways of writing the same thing, right? So we wrote it in one of the versions. What do you think is the other way, and what's the problem with this way?
Another way you could do is like define the class and then have just run callback with this information in it. Like do like a const new whatever new images equals new promise and then run your callback with information. Okay.
So you're can you guide me through it?
Yeah. So you do like const and then some variable name. Images.
So let's do get images -2
Equals new promise.
equals new promise.
That's based on. Then in parentheses put like. In the parentheses we put like the callback or callback. And then the function.
Resolve and resolve.
Yeah. Or yeah, like that.
Okay.
Yeah.
All right. So this doesn't confuse anyone, right? Like this is a one-liner because of arrow functions, right? This is essentially just a one-liner. Like when you have an arrow function. Oh wait, what? Sorry. No. You mean this, right?
Yes.
Yeah, sorry. Yeah, so this is essentially a one-liner using arrow functions, right? So basically when you have an arrow function and you have one line, you don't even need the return, and then you can just return the promise, right? But I mean, like, yeah, this is another way of doing the same thing as the other one, but this is not really what I was talking about. Jorge?
I just want to talk about the drawback here.
Wait, what?
That drawback on
Yeah.
we're not handling either. And
Without that, let's say another reason. Why do you think that's? So the question is, what's the drawback of the first function of this, the one that we just wrote, this one? It's what? Long and ugly. Why is it long and ugly? That's partially the reason.
Well, I don't know. I was going to ask, but can we take the beginning part?
You're getting closer, all right? So what I was suggesting is, right? What I was suggesting. So how do you invoke this? Get images in page. How would you invoke that? Like how would you use that function? Yeah, how do you use it?
You type the name of the function.
Okay, so what's the parameters?
Page URL and then
Page URL, page HTML, and how do you call the callback? Huh? No, there's no promise yet, right? Yeah, the anonymous function, and what's the?
Parameters we could see where the images and
I could call the parameter anything I want, right?
Yeah,
Right.
that's essentially what we get.
So this is how you use the legacy code, right? Anyone confused? What's wrong? Like you guys see like you guys are so in that promise mindset. You guys are forgetting the basics, right? The callbacks.
That kind of defeats, isn't that kind of, yeah, the purpose of promise?
Hmm?
Doesn't that kind of defeat the purpose of the promise? The purpose is to avoid callbacks, right?
To avoid callbacks, yes.
So we have-
In your application code, right? But is this the application code?
What's that mean?
So yeah. So yeah, I'm gonna start throwing out these words a lot more, right? These terms. So application code would be basically like for example, in your Express app, right? Say you're building an Express app, in the actual routes, like the route functions, that's the application code, right? That's directly the application that's interfacing with the user. And then this would be more of like a service, right? This is more of a library or framework that can be used in whatever product or application that you want, right? Make sense?
In other words, you don't want to have callback inside the function, but you can have callback as a parameter.
Wait, what do you mean?
Okay, like, you know how we have callback here for
Yeah.
images?
Yeah.
That's as a parameter. It's being passed in as a parameter.
Uh-huh.
But
Just like when you do array.map, right? Right? For array.map, you get back everything as a parameter, right? Like it's a callback, right? Array.map is a call. The parameters of callback, right? And then it's the element, the index, the original array, right? Right? That's basically how the original legacy code is working, right? You're invoking the function, and it's giving you back callback, right? And the callback has the results, right? So how would I finish this? How would I finish this code? Make it work, just like the first function, like this one. Resolve, and then wrap it around what? Array of images, yeah. Yeah, these are two different ways of doing it. And why do you think, what's the drawback for this and what's the drawback for that? Like, which return? I mean, they're both returning promises, right? It's honestly, this code works exactly the same, but it's honestly like a design preference and decision difference. It's like it's a design thing, right?
Can we assume that the second case, starting on line 32, is what's going to be more common, or we can see more often?
Well, it depends, right? So for example, like if you're where would you see this more commonly? The thing that you brought that up. Where would you see that most commonly? Let's say you're working on like your capstone.
I would assume well, both functions, which are just grabbing legacy code and they're turning it into functions that return promises, right?
Yeah, but what's the first one? Is the first one invoking legacy code?
Well, no,
It's just using, copy and pasting it, right? The second one is what? Using it, right? Actually using it. So the first one, the benefits of that is that if the legacy code gets outdated, you don't have a dependency to it, right? And what's the second one benefit?
Reusability. Like easily invoke it. You don't have to constantly rewrite the legacy code over and over again to read it.
Yeah, and where and in real life, right? Like where, like how would you, like where would you experience this? You would experience, you'll see, like, because like, what if, you're using an NPM module, right, that someone else made, and it's like some really complicated thing, right? Are you going to go inside the source, extract all that information, extract all their code, figure out all that logic, and then assemble it yourself? Assemble it yourself? No, right? Huh? Very unlikely, right? Right? So that's what this example is basically showing. You can use other people's code and wrap around it, right? And make your own use for it. Okay?
Modules.
Yeah.
Servers.
Yeah. Cool? All right. All right, so problem 2. So before you guys start problem 2, so what is the request module? The request module.
It gets back to HTML page or whatever URL.
It gives back the HTML page of whatever you call, okay?
Isn't it like the one you use in the browser, XML?
Yeah, it's kind of like, it's kind of like this, right? Right? So where do you remember this from? No, I mean, yeah, API calls, but like which unit and like what? Unit 2, right? And why? What is this used for? I mean, where is this used? In the browser, right? And why are we using this in Node? Because it's browser specific, right? So, what? An NPM to download this? Request? Yes, you have to get a request.
Oh, shit, that's, yeah.
Yeah, but not this.
Yeah.
That'd be scary if someone made an NPM module to get this. There is?
Yeah.
To get this exact XML?
Well, I don't know if it's the exact, but there is an XML HTTP process.
Module? People come up with everything. Yeah, so what's interesting about that? Like on the browser, you're using this, right? And then like on Node, you're using this, right? What problem are these two things solving?
You're using this and what's the other one?
What do you mean? What? You guys are now like, what's the shit? You made me forget the question. Shit.
What's the use of this?
No, what's the problem? Okay, what's the problem that both of these things are solving? Like the request and the XML. Like, what are they both solving? What problem are they solving? They're solving a very specific problem. Asynchronous what? It's not. It's more than a GET request. But what is a GET request?
It sends out a request to the server.
So what is that? What through what protocol?
HTTP.
HTTP protocol, right?
Yeah.
So these things, these frameworks are allowing you to send HTTP requests, right, to another server or other application somewhere, right? It's not specific for APIs. It's used very generally. Okay. So for example, didn't we show you like yeah, so like so if I do like curl okay, very smart. Okay, this works. Cool. So what do you see? Can everyone see this? I don't think I can. All right, you guys see this though? It's basically Google's source. All right. I mean, it's what you do, what you see when you do view source, right? So basically, right? Like this is a very like common thing that happens. You have applications and programs sending HTTP requests, right? Outwards, right? And then you get back some sort of information, okay? And in this case, what kind of information is this? It's HTML, but what kind of data type is that? It's just a massive string, right? Just a massive string. So what do you think would happen? What do you think would happen if I copy this image address, right? So image address, what is an image address? What is an image address?
Server request.
It's a server request, and it's also where the file lives on the server, right? So what would happen, do you think, if I do curl and I pass in this?
Yeah, probably. After the image. Okay, that, where you get HTML.
Who thinks we get HTML?
You get the URL.
So I'm doing the same curl command, and I'm gonna get the image URL, right? What do you think is gonna happen? So let's do it. What is this? Yeah, it does that. What is it? What is this?
Code for the image itself.
It's not really the buffer. It's close to the buffer, right? But it's actually, yes, it's actually like the I think it's bitcode. I think so. I'm not totally sure. But yes, it is a type of string. Essentially, it's a type of string, right? And this string makes up the image. Okay. So yes. Yes. So essentially, technically, you could copy and paste this entire string, go to a notepad file, paste it, save it as an image, but you have to make sure it's the exact extension, the same exact extension. Save it from a notepad file, paste this, right? Save it, and then double click on the file, and it will open up the image. Okay? So what does that tell you? Data is just, all this data it's literally just strings, right? And it's being passed from one place to another, okay? Yeah, and that's why like understanding how to properly do like HTTP requests is so important, because everything is essentially some sort of request, okay? Either you use the HTTP protocol or you use like things like sockets, right? You use different protocols to transfer data in different speeds, okay? So for example, like chat messages, right? So when you're on like Instagram DM or like Facebook Messenger or something, it's probably using like a socket system, right? Where it's transferring the data in real time, okay? But this, back in the day, all data used to be transferred usually through HTTP requests, all right? Even like the chat data. So how do you think like they would try to get the chat data, like to make it real time, quote unquote? So right now, like in modern technology, right? Usually like chat systems, chat rooms and stuff use some sort of live connection, live protocol like sockets, right? And that's how they transfer their data, all right? But back in the day, all the information that was being sent from one place to another was all HTTP requests, basically, right? Usually, right? So how do you think, like, let's say you're on like AIM, right? Right? AIM probably didn't do HTTP requests, right? They were too big for that. But let's say you're on like some sort of chat room, and yeah, right. But like let's say it's using HTTP requests, right? How do you think the chat room is waiting for the new information to come in, right? Like let's say I'm chatting, like let's say we're all in a chat room, right? And I just sent a message. How does your computers know that I sent a message? It doesn't, right? So how do you get the new information? Did someone say something? Jay?
Is it maybe like a set timeout function that keeps making calls
Yes.
every time there's new information, and if there is, it pulls it?
Exactly, right? So back in the day, that would be called polling, right? Where you would literally have a function that's running at a set interval over and over and over and over and over again at the same HTTP URL to make sure that if there's like a change in information or not, okay? So just, yeah. Good to know. All right, so let's work on problem 2. I think some of you already worked on it. Like you were asking questions about this. So let's take like 5 minutes. I think. You don't know how to download request?
No, like, yeah, 10 minutes though.
Okay, bro, that takes like 10 seconds. So back end or front end? What do you guys like? Back end or front end? Full stack? Good answer. Yeah. Once you learn React, a lot of you will be like, fuck backend.
I have a question.
Yeah.
So like right now, this is going to like use the server only for like dedicated dependencies and have most of the functionality in the client, or how does it work?
So usually, the client is always just a vessel. And what I mean by that is like, the client is almost always used as something to just show the user, okay? And the reason for that is because whatever you give to the client, it's very risky because whatever you give to the client, you can reverse engineer it. Okay, even if it's like an Android app or iOS app, you could still, there's still ways of reverse engineering it. So you don't want to give your critical business logic in the client. Okay.
And that's how.
Your business logic should be in the back end. Like your major like secret sauce. Your secret sauce.
So like that, back in the day, they did HTTP requests, but then now it's different when they use sockets.
No. They still do HTTP requests,
Yeah.
right? We're not teaching you outdated shit, right? But like sockets are for like live things, like chat rooms and like live games and stuff.
How does that work?
So maybe we can teach you like Unit 5. But basically it's kind of like on the DOM you had event listeners. So there's like event listeners, and like the server emits something, and then the client listens for it. Yeah. Are we gonna do React Native? I want to teach that. Yeah. You guys want to learn it, right?
Yeah, Unit 6.
I mean, Unit 5. Unit 5, there's a lot of space for us to teach you stuff that we want to teach. Like, Talk really wants to teach you guys testing frameworks and things like that. So yeah.
Teach more than the day's class.
What happens?
Teach more than the day's class.
Teach you guys more than the base class?
Yeah, make sure we get more.
We've been doing that. You guys. No, I mean like we take it at a different pace too. Like take it at a different pace.
And we're not ready for it.
So, I have a question about like React Native.
Yeah.
When you make smart forms, exactly, right?
No. Use this. Yeah. What's up?
When you go something like on React Native, how do you set this, like, I know like this is easier to just like the same over all the devices, but how do you
Oh, you will actually run it on an actual. Let me show you.
What? What's the question?
testing your app is React Native?
So this is what the iOS class does. The iOS class. So they run. They use Xcode. So but Xcode is only for like Macs, and it's like the required IDE and program to build iPhone apps. But basically, what will happen is you will run your React Native code, and then it will open up a simulator that mimics the actual phone, like that has like the actual operating system and stuff, and then it runs the app on that basically.
Is that Swift?
Yeah, that's right.
And you said that with React Native will be able to build iPhone and Android apps?
Yes. So basically, the whole purpose of React Native is like you use HTML. No, you use JavaScript to write cross-platform apps. So that same the same code can build an iPhone or Android app. Basically.
Yeah, awesome. So basically, you're in the right spot.
I've noticed that some of these social media apps, like Twitter apps, are pretty much just a website that's being kind of put into. They're
very big companies, and they have pretty they have like performance like requirements and stuff. So they're definitely those are definitely native apps. So there's this thing concept of native, hybrid, and HTML, CSS apps, right? So like good to know, like back in like 2011 and previously, all like the Facebook app was actually just like a HTML, CSS, and JavaScript wrapped around native code. So it was like the actual Facebook app was like you were on the Facebook website. Yeah. But now it's native.
So what's the difference between that and like a progressive web app?
So progressive web app is kind of how things are leaning towards nowadays. It's like, so JavaScript and like web technology in general is getting way more advanced. So it allows you to do more powerful things. Like now we have access to things like local storage and stuff, which we didn't have access to before, right? So like you can start mimicking like why do you need like a physical device, right? Like so like a progressive web app would like make use of like the microphone and like the the camera and things like that. So like your website making use of like physical hardware things.
So would it be like reverting back to how it was originally, with like using CSS?
Yeah, but that was more depth.
Yeah.
I mean, so like for example, like Airbnb's app. I don't know if you guys ever used it. It's pretty nice, right? It's been built with React Native for a while, right? But then I think like last summer they decided that they're going back to native, and that was a major like whoa, like Airbnb's doing it, right? So yeah. I think it's design. There's certain, like it all comes down to like design, right? Like there's definitely like flaws with technologies like React and stuff. And it's made by Facebook. If you didn't know, React is made by Facebook. Yeah. You guys are just like, all right. So Redux is like it's not gonna make sense at all right now, but it's like a universal state management system for your entire application. All right. But yeah, that's basically how it is. Mhm. All right. Yeah.
So then we read a manage all of the states of contact components at the same time.
Wait, what?
With Legos, we can manage the state of multiple components.
Yes. Yes. It's supposed to like unify it in one central place, basically.
And
It's like I think you've done iOS before, right? You've heard of the singleton pattern? So it's kind of like that. Yeah. All right, so let's go over problem 2. Everyone good? I know I was babbling, but cool. So what's the first thing I need to do before I even write any code? npm init. And then install the package, right? So npm install All right, cool. So what's next? Uh, yeah, you don't know the code for request, right? Because this is the invocation of no, like no, you get what I'm saying, right? Like this is the invocation, right? This is you invoking request, right? It's not the function definition exactly, right? You can't go inside. Well, you can, right? Let's see if we can. See, yeah, you see. Do you really wanna? No, right? Like, there's probably like a lot there, like using multiple files and stuff that you don't even know, right? So you don't want to touch that stuff, right? So it's better to go with the second method where you're wrapping the invocation itself, right? So what do I do? Pam? Const URL. You want to call it URL? Yeah. Okay. And then? So should I do the one-liner? Cool. So where do you do this? What goes first? What does the order matter? So these are questions, right? Huh? So the way you're saying I can do this, reject error like that? Really? So there's no problem with that. What if, yeah. Okay. So why did you have to do that? To know if there's an error and then do that, right? And not do the body part, right?
Do error before.
Oh yes, thank you.
Also do the reverse way if resolve body or if body then resolve.
I'm not sure if bodies ever null. It might be. Then definitely it would work that way. But I know for sure that error is null if there's no error. All right. You get what I'm trying to say?
Yeah.
Yeah, that's it, right? Console like what? Where? Where would you do that? So URL dot then. So what would this give back? Body, okay. Right, and then, yeah. Right, but okay, so let's test this. works just like our curl, right? But what's the only caveat and problem here? It's not reusable, right? Why? Yeah, because it's hard coded for Google, right? So instead of the URL, we should change this to Google, right? Right? If that's because that's what it's doing. So we would want to take in a parameter, right? So let's change this to, because I want to name the parameter URL, right? And we want to change the name to like, should we change it to? Get body? Let's make it yeah, whatever, get a URL. So what would happen if I pass in what would happen if I pass in this image address? So what will happen if I invoke that? Yeah, I'm getting that crazy thing again, right? Oh wow, what? What is this? It wants me to print that? Never mind. Anyways, but yeah, it gives me this, right? So we know that this, so like as backend developers, you kind of have to understand like the flow of information. Is this a buffer? Is this data type buffer? No, right? How does buffer look when you console log buffer? Pairs of numbers, right? And it actually says the buffer data type name, right? So how do you think I can convert the body into a buffer? Huh? I want to make it into a buffer because a lot of libraries and frameworks and different functions, you'll see that they take a buffer as an input usually. Okay. Nicole? Why would they take buffer as an input? So the way Node is designed, so Node is meant to be like a massive it's meant to be like a language that very easily and nicely handles like asynchronous requests, like a lot of concurrent requests, right, that come in at the same time, and process it bit by bit. Okay. So because it processes it bit by bit, that's what the buffer data type is meant for. So yeah, so basically, like, I don't know if we're gonna go too much into it in this unit, well, this class in general, but Node is good at things like as you're getting the data, it processes it and transforms it and then streams it back out. So imagine like you made a Node server that like does like video group video calls, right? And like that Node server like as you like let's say you're you're talking to someone and like it's streaming that video, it can take the bit by bit video information and like add some sort of filter to it or do some sort of transformation to that video. That's what it's good at, and that's only possible if you have that buffer, okay? Because the buffer comes in bit by bit, which is yeah. So how do you think? Yeah. New buffer, yes. So you do const buffer is equal to new buffer, and you see how it takes in a string, right? So Yeah, you just pass in the body. And now if we console log buffer, you'll see actually there's a buffer, right? Which is less ugly to deal with and it's more useful. Okay? But that's only useful for things like images and videos and things like that, right? But if you're actually getting like JSON data or you're actually getting like text or HTML, right? It's more useful to keep it as a string, right? Make sense? All right, cool. So let's work on.
Ask one question.
Yeah, what's up?
So I didn't do that then. I didn't resolve console log one. So
Wait, what do you mean?
so you see on line number 8.
Yeah.
Resolve.
Yeah.
Body and console log one.
So console logging body wouldn't give you body back, right? In the promise chain, you wouldn't have access to that data in the promise chain. The whole purpose of resolve, passing in information to the resolve, is so that the next promise in the chain can have access to that data. Make sense?
Why don't we need an else?
Oh, because once you run reject, it just stops. All right, so let's work on problem 3. Oh, okay, shit. I didn't explain Axios yet. So anyways, going back. Yeah, so you see how like we have to kind of come up with our own promise-based request function, right? That's kind of annoying, right? And you would probably have to do this for the front end and the back end, right? So how would you do it for the front end? We just did it for the back end, right? We wrapped our promise around request. How would you do it for the front end?
Wrap the promise around the X.
Yeah, you would have to wrap a promise around XML, right? And then you have like these 2 different groups of code and like it's annoying and it's hard to maintain, right? And not only that, this is easy right now because we're only working with get HTTP requests, all right? There's way more. There's post, there's put, there's delete, right? So you can't do all that like right off the bat using the code we have. We would have to modify this function and make it more complicated and all that stuff, right? So that's why I'm introducing this thing called Axios, all right? So if you go npm Axios, so it's both a back-end and a front-end request framework, okay? So it's very important that we start getting ourselves familiar with Axios because we're gonna also use this in the front end using React, okay? So we're gonna use this in the back end and we're gonna use this in the front end, right? Yeah.
I thought that NPM modules only worked for Node.js, but this is one that works for also for the front end.
So for the front end, if you're using a basic like simple vanilla JavaScript app, you could just put the script. So that's the Axios library basically.
Okay.
That's this.
How I would think.
Yeah.
I would do an NPM in.
It would do the same thing as npm install and then require and then require.
But let's say
Yeah.
I'm creating a web app. It's a web app and it's all front end, and can do an npm in it, and npm is installed.
Not right off the bat, no. Okay. We'll talk more about that stuff next unit when we talk
So
about it.
right now, I want to use Axios, I need to do this.
Yes, yes. Any questions? All right, cool. So Axios is actually very simple to use, and it's kind of a blessing that we're using it, right? So, yeah, you guys are gonna get mad at me and Talk for not introducing this in like unit 2, right? but we wanted you guys to like really like experience the hardships right? And really understand how things are like at a lower level. Okay. Day's class introduced it, but we did. But yeah, so basically it's very simple. Okay. So to do a get request, all you have to do is do Axios get, right? And then pass in the URL, right? And then it works as a promise. It returns a promise, okay? And the promise gives you back a response, and then if there's an error, just catch it. That's literally as simple as that for the time being. Yeah.
I just wanted to say we appreciate that. You made us go through the hard part so we actually learned how to
You're not appreciating?
No, we didn't. I'm pretty sure everybody does. So
Trust me, like if you go to a hardcore old school interviewer, right, and he asks you about XML HTTP request, you'll be like, you'll know it, and then he'll be like, oh wow, you know, this person is beyond a regular boot camp, you know?
Right.
Yeah. This also doesn't look like
Why?
I don't know. It's just yeah.
It's too easy?
So.
Okay, so let's test it out, right? So I'm gonna, no, I mean, I have to show it. I have to show it, right? So like, yeah, so I'm gonna do npm install, same thing, right? It's a framework that you download from the internet, right? So npm install Axios. And then you do const Axios equals to require Axios. So all I have to do, right, is just do Axios for the basic usage, right? There's many ways you can use Axios and customize it and make it more powerful and more useful. But for like the most basic case, right? For the most basic cases, all you have to do is say, okay, Axios, I'm gonna use you, right? Dot get, why get? Because it's a get request, right? And then you pass in the URL, and then that's it. You just do then, and then you get back the response. So Axios is response it gives back a promise, yeah. So that's why it's also amazing, right? So yeah, and there's another thing I'm holding back. There's another thing I'm holding back personally about promises that we're not gonna teach till like next unit. And then you're gonna hate us again, which will make promises even easier. Okay, which is async await. All right, but yeah, anyways. All right. No, don't look at them. No, I want you guys to like. We need you guys to like know the syntax and stuff, because when you go for a job, like they expect you to know things like this. All right, so it's important. Like you know, like there's more modern tech that comes out, obviously, that makes things like your life easier. But like as I'm saying, right? Like most likely the companies that you're going to be working for will not be using the latest cutting edge stuff. Okay, so you need to know things like this. Yeah.
Yeah, I was going to ask about that. Like, is async await like saying is it like a new feature?
It's a new feature. Yeah, it's from ES7, I believe.
So can you compare that to the way we did it before? How was it before?
You forgot? Go back to unit 2. Go back to unit 2. Yeah. So it was XML HTTP request that hold like monstrosity wrapped in a custom callback function that you would have to define yourself.
Yeah.
Right?
You have to create an XML HTTP request object with the new HTML, and then do that object get URL, and then callback.
That's only with the browser, now Node.js.
Right.
Node.js was request, right?
Yeah.
The code is literally here, dude. All right, so yeah, so basically let's test this out, okay? right, so I'm gonna run this and let's see what we get. Cool. So we get the HTML, right? But here's the thing. It's too much. No, it's not a photo. It's just this page. Anyone know like a really simple website? I mean, it's
Oh, I know.
what? What?
Motherfucking
Motherfuckerwebsite.com.
website.
What does that have? Is there? Am I gonna get fired for going there?
It's just text.
Okay. So motherfucking website.com. Okay. Yeah, this is pretty simple. Cool. Who the hell made this?
I thought Alex made that website.
Yeah, that link would be worth
Yeah, that's probably worth thousands of dollars or more. All right, cool. So as you can see, right, we get the HTML, but this is all wrapped in a more bigger object, all right? So the response object is actually not that simple, and it's good that it's not that simple because there's more information that we need to care about in other circumstances that we don't usually care about, right? But as you can see, data, colon, HTML, right? So if you just want the body, okay, just like a request, you know the body, right? It's response.data, okay? Data response is a JavaScript object and it just holds a lot more information, okay? And there's actually a lot of useful information here. Like there's things like current URL, there's just a lot of stuff that we will use in the future. It even tells you like what kind of method you use. There's just a lot, okay?
That's how we used to get that's what we used to get from the XML.
Yeah, I mean, they all usually get this type of data, but yeah, right? So does that make sense to everyone? So like another thing, like,
It's a lot more.
all right, so for example, right? There's this thing called a user agent, all right? So
So that would tell you like what kind of device you're using.
exactly, right? So for example, right? There's certain APIs that's it. I'm trying to make it not complicated. So imagine you are building, all right, first of all.
I feel like you're gonna say something you don't want to say.
Yeah, I mean, that usually happens. But, because I was going to talk about some hacking thing. But, so like, this is pretty powerful. Think about this, right? This is very powerful. Being able to access any like website in the world and get the data fed to you in like 2 lines of code or less, right? It's pretty powerful, right? And you could use this. This is used to make things like crawlers, bots, like so many different things, right? So many different programs are like you use something like this type of concept, right? So, how do you think when Google first was invented, right? Like, how do you think they did? How do you think they did their stuff? Like essentially build their crawler. So Google crawler version 1, right? How do you think that works?
I guess you type in the keyword and then it would let Google everything that's on the internet.
But how does it know the things on the internet? So for example, when you go on Google, right, and you type down stuff, and you immediately see all these results, right? Where is that stored?
Probably have a dictionary.
Okay, yeah.
That they, and then like those words have a link to a web page.
Okay, so essentially they have a massive database that stores and maps, right? Stores and maps links with words, keywords, right? Where do you get the keywords?
Where you know.
User. Their header.
Okay, that's one place. But generally, yes. Where do you get, like? Let's say you write an article, right? Your own blog, like I don't know, like blog about the vegan food that you eat, right?
You can buy it. Because you're
Yeah. So let's say I write an article about my diet, right? And I post it on my blog. Where's like let's say I write something about avocados, right? And if someone searches on Google avocados, right, you'll probably find my webpage, right? How does that happen, right? Like, where are those keywords coming from?
Google crawls your website just for those where everything and based on your SE saves that and makes it.
So do you think like as you're typing the letters on Google, Google sends out like its crawler to crawl every single website in the world, or is it predestined? It's already there, right? So that means those words have probably already been crawled previously, right? So essentially, that's how Google was invented. Like people found out that, hey, I can do something like this, right? I can get the entire HTML of a page, right? Which is essentially just a string, right? This is like Larry Page's, what's the other guy's name? Serge?
Yeah.
Yeah, whatever, right? No one ever remembers his name. But that's what these guys were literally thinking about, right? Right? Like, oh wow, like this whole HTML thing is just a string. Why don't I do dot split, right? Break up the entire string, get all the words, right? Now I have all these words that map to this URL. I already know what URL I'm on, right? Because I went there, right? So let me map all these words on this page with this URL, right? And so that if anyone searches these words, I can link them to this URL. That's basically the foundation of Google, okay? And then it goes beyond that. It goes a little beyond that. Why is it a crawler, right? What else can you do if you have the entire HTML of a page? How is the World Wide Web connected? Through hyperlinks, right? So if you can see the entire page, right? Can't you get all the links in the page too? So what does that do for you? You go into this page, you crawl all the words, and you map it, but you can also find all the links. And what do you do with those links? You go to them again, and then you wrap them in. It's like a recursive function, right? It's a recursive function that keeps finding links in different pages, goes to the next link, gets all those keys, finds those links, keeps going. And that's literally what the Google crawler did to find everything on the internet, right? Because one thing is connected to another thing for sure, right? Yeah.
So like crawlers never.
They probably end, yeah, definitely. But they definitely hit a wall at some point, right? But yeah, so anyways, going back to that, right? So I just want you guys to appreciate how simple and powerful this is, right? Like you can do a lot of stuff with this, right? Like literally build so much things with this. And so going back to it, right? So when we get up to next unit, I'm going to rebuild our React app, right? So our React app is the client, right? Which is also technically the user agent, right? So there's a way, like, so imagine like, let's think like hackers for a sec, right? Imagine you wanted to crawl a certain website, okay? But they denies you. How would you go on about crawling that website? Even though they deny everyone except probably one thing, right? Robert?
So like pointing to the user, you just somehow change that to something that the website would accept.
Yes, exactly, right? So basically, right, there's a lot of websites and places that have pretty valuable information, and most likely they don't want like just anyone crawling their data, right? So they would reject any kind of request that's coming from a user agent that's not Google crawler or some sort of like, you know, something that they would trust, right? And a lot of like even like iPhone apps and Android apps do that. So like obviously like, you know, when you're using Facebook or Instagram, the app itself is sending a request to a server, right? It's just doing HTTP request to get some data, right? Do you think like Instagram wants just anyone using that same endpoint to like, you know, get their data, or only their app?
On their app.
Only their app, right? So in cases like that, if you wanted to still get their data, you would disguise yourself as the Instagram app, basically, which you can do if you change the header. So things like that. Right? Yeah.
So what's your robot?
Wait, what? Oh, we'll learn that later. That's not gold, but it's really simple. Like if you look at the Axios documentation, like you can literally find that. So like, there's literally like there's a lot of configuration and stuff, and it's literally like simple, like it's just simple JavaScript objects that you modify.
So that's what you need, like if you want to access, let's say Facebook, right, and want to log into it.
Yes, you would have to pass in like authentication information, right, to log into it, right? So things like that, yeah. Right. So cool.
Is that what like the means do? Is connected to Facebook?
When they're doing login with Facebook,
Yeah.
Facebook has their own like login system that everyone uses, basically. Yeah. Is that a what? No. Yeah, it's not. Sorry. I think. I mean, this is. Do I really need to cite this? Which part do you need me to send? All of it? Okay.
Correct.
All right. So let's work on problem 3. Right. So now that I explained Axios. So using Axios, right, and the function that you built in problem 1, right? So you're going to use Axios and the function that you built in problem 1 to get all the images from a web page, all right? So your first crawler ever, all right? So basically, you should be able to pass in a Wikipedia page like that, right? And get back an array of all the images on that page. Okay. All right, cool. So, I think there is ways to do it. But I mean, I think like it's just the way, like, I feel like HTTP is still a very outdated technology in general, and there's some limitations to what you can pass. And what no, HTTPS encrypts, yes. So HTTPS does the encryption without you even have to worry about it. Like you don't have to program it.
Let's say the agent, like using any agent.
That's if the server is HTTPS. You have to register your server to HTTPS.
So I guess if you have a website that is in
HTTP, it's pretty.
I was going to use HTTP.
Yeah, you're done if you do. But like, you know, when you're developing something, you're using HTTP. But yes, like for example, like let's say you're sending data through like HTTP, right? And someone in your router can like be a middleman and like see that information. So if you're passing in some like username or password, they can see that.
It goes as text.
Yeah, exactly.
When does it get encrypted?
So it depends on where you want to do the encryption. You want to do it in the front end or the back end, but
Which we have.
encrypting in the front end is pretty expensive because the encryption functions take like performance power and stuff. But yeah, like things like that, you definitely send to HTTPS.
Yeah, actually,
Oh, so Redux is kind of like that. So it's like a central place for you to store all your statements, and then use it back on whatever component and update it. Track your data, like wow. How are they tracking your data?
So if you were to do it nicely, right? There's so like
So yeah, so I mean, you would never be able to access things on Facebook that you're not allowed to access. So Facebook, like you can't see the newsfeed unless you're allowed to use it.
yeah, but let's say I'm doing something else.
Yeah, but then it's gonna know it too. You're sending your authentication information, so it knows that it's the user. Yeah, this stuff can get really deep, which we can't really cover all of, you know, in a course like this. Like you can literally have like a whole bootcamp just for backend, because backend is just so much. Like yeah, like I wanted to do like a problem. I don't know if we'll have time. Like you take an image and it like resizes it in the server and gives back the resizes image, or like makes it black and white, things like that. Oh, okay. I can show it. It's really easy.
So you did another library?
Yeah, it's another library. Yeah. I mean, there's multiple. There's a J. I think Jim is more better. But Shark is more. I think Shark's faster.
Get back. Right, not the correct to do option methods to get the images from there, right?
Which images?
He said, is that to get the images?
Yeah, so all the images in the web page. So you should get back an array of strings.
And the function of the problem, so you want us to use that.
And basically, use the function that you got.
When is this one started?
You're gonna need two promises to solve this problem. It's a chain promise. You guys thought of any ideas for capstone yet? Or the hackathon? So you're gonna need one for hackathon and another idea for capstone. Hackathon is like 2 days. You literally have 2 days to work on something. And then capstone is like a month and a half, I think. Make sure you make the capstone like a worthy project. Because it can really help you for finding a job.
They're all like $1 million.
What happened? Because in the past there's been people that like they don't have good synergy with their team, and then like at the last minute they just hash out whatever, which is unfortunate.
Speaking of team, when do we find out about that?
Yeah.
Oh, we'll do that like Unit 5.
But you really think about it now. And it's gonna be assigned or like?
I think you'll get like preferences, and then we'll put. We're gonna try to evenly distribute like people good in design, people good at other things. And it could be pretty like, it doesn't have to be basic. Like in the past, like one of my friends, he was in this program and he was in iOS, and he did like a smart mirror, like a smart mirror. So it's like they took like a TV. Yeah, so they took a TV and then they like connected a Raspberry Pi to the back, and then like they added like this glass over it, so it's actually a mirror, right? But you can also see through it. You can see through like the whatever's coming from the TV. So and they're iOS, right? So they had a mobile app that like as they like change the widgets, it changes it on the TV basically. Yeah, it changes on the smart mirror. Huh? Yeah, you could build shit. Yeah, whatever. I mean, it has to get approved, but yeah. But if it's something cool like that, we're definitely gonna approve it. Oh yes, yes, yes.
Like, it's like a long.
I get what you're saying. Yeah. I think we'll try that like the end of this unit, and then next unit mostly. Yeah, we'll try that. I don't know about labs, but yeah, it is a lot of hard work. It is tough, like working in a team, and like making sure that you guys are all branching properly, so you guys aren't fucking up each other's code, and there's no like merge conflicts and stuff like that. But I mean, if you follow like the design patterns we're teaching you, you shouldn't have merge conflicts. Like if you're breaking things up into service files and things like that, shouldn't. The only time you'll have merge conflicts if you're all like working on like one massive file, which you should not be doing. Yeah.
Let me export the file one. Export. Do export. So like like I said to use the function we created.
Oh, you just copy and paste it in that file, whatever.
But like just to be like fancy.
Yeah, you do you. Yeah, sure. Yeah, of course, yeah. Let me see.
I use that too. Yes. I use it.
I put it in Slack, all right? I put the files on Slack for those who need it. What's the coolest project I've seen from like Capstone? I mean, I haven't seen much. No, I mean, I haven't. No. I mean, I haven't seen many like Capstone projects. I only saw like last year's Nights and Weekends web class and that iOS class because my friend was there. But yeah, from my friend's class, I don't remember much, but I only remember his. But usually they're just like apps, they're like basic services and apps and stuff. And then like I remember like last year, like the web class, like they did like a very like it was a very cool like. You ever heard of like the game League of Legends? Yeah. So like there's different champions and stuff, like different characters you can pick, right? And like they basically use the League of Legends API and like you select, like you build teams, and it basically tells you which team is better against what team. It's like a tool for that, but like the overall like animation and stuff for it was like really top notch. Like, people usually get wowed by like design and stuff, just to like So make sure your team has a good designer. Okay. It's not working.
This basically gives you a very strong.
So then we'll do back and response. So you just it's more. So you do response dot data, which is the body.
Response dot data. Okay. So that
No, no. So you give back response. You can't do it in a call. And then over here is so we can do response.
and then I put this pops up. So I want to return.
Yeah, but I was trying to. So you want this entire function to be a problem. Anyone need more time? Can I go over it? All right, cool. Yeah.
So when we just did the actions again, and then I did this, and we had the URL. It didn't show me everything at the top like it did like the regular. I don't know if that's because the actual one didn't show it all, or is it because something else?
I think it's not showing it all, but
So should we just put up?
yeah. So you should be doing response.data. What?
The map is at Cheerio.
Yeah, it's not the array map. Yeah, yeah.
We're so confused by like why is I.
Yes. I was confused by that too. Yeah. All right, so so these are the three dependencies I need, right? I need the Cheerio, I need the URL, and I need the Axios, right? And then I'm gonna just copy the. I'm just gonna copy this over, so I have it, and then I think I'm good to go. Okay, so let's see what it's called. So I gotta make a function called get images from, and what's the only parameter it takes? An URL, right? And what is so when you're thinking about this problem, you definitely know that you're going to be chaining promises probably, right? Right?
Yeah.
So what's the first promise, and what is the first step into solving this problem? Why Axios first? Because you need to get the HTML, right? Cool. So I'm going to do Axios dot get what? URL. And then, not then. What does that then give me? It gives me a response object, right? So
The other URL, I want to change the name. Like, you know how we use library for URL, the document required? Are we gonna reuse that?
oh, I get what you're saying.
Yeah, but this is that's the same name. So like
I think it's gonna assume it's the parameter. Yeah.
Oh yeah, I know. But I mean, like inside of get images from, we end up using it, right?
I think it will still work.
No, I'm just saying like it's,
It'll pull from the closest scope.
oh, no, I know that, but I'm just saying like if you were to use URL.
Oh, in here?
Yeah.
Yeah, then it would mess up.
Right.
But let's just keep it simple for now. So, all right, so what's next? Now that I have the data, now I use the function I made, right? And I pass in the URL, and I pass in what? Response.data. Why response.data, not response? Response.data actually has the body. It actually has the HTML content, right? Response is the entire object, okay? And what do we know about this function? It's a promise, right? So I'm basically returning a promise, right? Right? And if I'm returning a promise, then shouldn't I also return Axios? Yeah, right? Because you have to chain it upwards, right? So whatever that function is going to return, you need it to be a promise too, right? Cool. So let's test it, right? So I'm going to do get images from, then I'm going to copy. So how do I use this? Yeah, not then, right? And what does it give back? An array of what? Array of images, right? Oh, yeah. Oh, I didn't install Cheerio. I thought I did. Cool. And now, whatever web page you pass in, you basically get all the images on that page, right? So we basically built a simple crawler, all right? Cool, so let's work on the last problem and just finish this off, all right? So, so create an Express server that takes in the following request. So you would pass in a URL, and the page will respond with a JSON holding all the image URL, all the image URLs from that page. All right? Oh, this code? So you guys can probably build your own search engine crawler now, right? Right? What would you have to do to build a search engine crawler? Like to get all the links of a page? Just change the image to a, right? Change img to an A, and you'll get all the links in the page, basically, right? Well, yeah. Yeah, you're like 30 years late. Huh? Oh, HR, yeah, it would change SRC to HREF, yeah. Was today's P-sets too easy? Because other days, like, I feel like we never finish P-sets. Or like, we're like cramming, like we're like trying really hard to like understand everything. So how did today feel? But you didn't feel like the P-sets were too easy? They were like, you're fine.
This is good for like an introductory or something.
Yeah, okay, cool.
Yeah.
Oh, it's configured to URL. That's URL doesn't have a dot at all. Who needs more time? Oh, yes.
It's already on, and then I could apply that then. This is bias insurance. First one. Yeah, but I think it was like. It's a selective type. So this would work if you get yeah. I want to get it. And then that's how you do it. There's a combination of this. You know what I'm saying? But it's unique as outside of the change. Yeah. I can do it the way this tries to do it.
So you did
whole thing. Probably has to be.
Okay, I put it with this.
You know, but this is a. No matter what.
It's in rock. It's in rock.
Oh.
Oh, yeah.
Yeah, it works.
Why does rest.json work?
Why? What do you mean?
Like, what does that do for like the rest of 10?
It forces the response to be JSON. All right, so yeah, so this is basically the code to problem 4. All right. So nothing special. We're just creating simple express app port, right? Creating the path, right? And then I'm getting the URL query, right? And then I'm just passing that into get image